We're recording. So, alright, today we're gonna be solving another ladder problem.
What is this?
It's a list of problems. By the way, two of my friends, I told them about this and they're watching right now. Literally in their room. Y'all wanna show up on the stream?
Tell about what?
Can I show your face? No.
Maybe later.
Okay, sure. Alright. Okay, so yeah, we'll just try to solve this ASAP. Yeah, let's get to it.
I'm the DJ.
How do I start my
I'll
timer?
be putting on some good tunes.
I forgot how to use this. Hold on. What, what the fuck? Now you're ringing the bell.
Imagine getting a copyright claim.
Oh, I actually might get a copyright claim.
No, because it's a
Wait,
copyright.
why isn't my wait, hold on. Oh, there we go. Okay. Okay, so I got my timer running. Alright, let's go.
Bro got the Minecraft Dream speed run, I remember.
Yeah, let's go. Okay, you've got an array, okay. Consisting of n integers, okay. Index from 1, okay. You're allowed to perform two operations. Okay, two operations on array 1. Calculate the sum of the current range on... Okay, so it's a segment tree problem. So from range AL to AR. Probably a second segment tree problem. Might be like square root decomp or Mohs algorithm. Apply the XOR operation. I hate XOR. I despise XOR with all I have. With a given number x to each array element on the segments LR, that is. Execute. So we apply an XOR on every single element in that range. And then we sum query. I think I've solved the exact same problem before.
Where?
Picture. Yes, I have. But it's a Diamond 4 problem, which means it's really hard, but it came out on a Div 2 comp. It's number E. Makes sense. Okay, this one's different though, because this one's online. Because you can literally... Okay, I mean, this one's also online, but you can literally add numbers. There's way more types of queries. So I guess this is like the harder version of this one. Yeah, because this is a translated problem. I'm assuming they got inspired from Codeforce, and this is a pretty common type of problem, I guess. So, yeah, let's get to it. All right, we don't need this. So basically, we'll just do the basic stuff. There's nothing to talk about this. Alright, we want to query type. If this is 1, we'll do something. I won't write an else because I hate else's. I mean, I love else's, but it looks cleaner this way. This is gonna be our sum on segments LR, sum of, and apply XOR X to segments LR. Right. Doesn't seem difficult. I'm pretty sure like most of the problems on the ladder, A2OJ ladder, whatever that is, they're pretty outdated. Let me pause my timer, cause hold on. Hey yo, let me pause my timer. What the hell? Pause. Why isn't... Oh, okay, so I gotta click on this to and then hit the pause button. Okay. Yeah, so I'm pretty sure. Okay, it says 1600 to 1700, but I'm pretty sure most of these are pretty outdated since the type of modern problems are pretty different. I assume these would be like more like 1500 to 1600. The latter ones being like 1600 ish. I don't think they're like. Maybe they are 1700. Because when you go into these problems, it literally just says 1800 after you solve them, and I don't think they're 1800 level. But yeah, especially this problem, I feel like okay, from I'm assuming implementation isn't too hard on this, but I might be speaking too early, so we'll have to see. We want to create a seg tree. We'll resize that here. I'm gonna add +4 since we're indexing in. We're using 1 based indexing. Do we need lazy propagation? Maybe. Because when we apply a query on, let's say, a range, we're applying that to each individual range. But is this like, can we solve this with a single lazy, and is that just it? And we just get the sum? Wait, holy shit, I think that's it. I think I can solve it really quickly. Hold on. David, did you know there's a technique called lazy propagation in segment trees?
Yeah, I heard about it, but I don't really know.
You use
Is it like updating things?
Yeah, you're like propagating updates. Like, there isn't your like username lazy on like every website.
Yeah. So I kind of reacted to
Lazy propagation.
You said lazy propagation.
Yeah.
Because he's actually lazy.
Such. Okay. I'll make my propagate. I'll just get the easy stuff done with first. If lazy is this, not if this isn't 0. We simply propagate. There's no way we can apply it immediately. Wait, no. Because it's a range update, it's a range sum. If it was a point sum, I could literally just propagate until we reach the end of each individual elements. But because it's a range query, we can propagate to that point, but we can't just apply to every single element. Okay, let's think for a bit. I have 2 elements, and we're gonna do like a XOR. I'll just use this as an XOR. And then we're gonna do that. And then we're gonna do that, and we want to represent that somehow in one query. Let's think bits. I'll just delete this real quick. Alright.
Did I disconnect? Yeah, you disconnect.
Let's say I have 2 random numbers, just whatever. And then I want to apply a certain XOR. Then is the sum of 2 elements and the XOR the same as the XOR sum? I don't think so, because... Wait, is it? Hold on, let's just try right now. There's no way this works, but that's our first one. And applying this one, we get this whole final segment. Yeah, so we're definitely off. That is not the strat at all. I don't think just by having a sum, you can immediately apply an XOR on that. Let's check our variable sizes. Okay, this amount of queries. We're sure we can't do most because it's online. I mean, we're theoretically really close to just doing and just brute forcing it, but it's like a bit off. It's like 50 times off, which isn't too bad, but I don't think that's the strat. Alright, if we... Oh, wait. Okay, lazy propagation itself isn't too simple because... Like, what happens if we apply 2 XORs? Yeah, what happens then? Wait, is this a symmetry problem? I'll just assume it's symmetry. If it doesn't work, I'll look for a different idea. But there's no way it's something else. I don't think there's a different type of query algorithm that would work with this. Yeah, is it? I don't think it's like parallel binary search is the only other query algorithm I know, but it's not query at all. I mean, you can't use PBS on this. It's irrelevant. So and there's no it's PBS and the div2 problem. I know it's E, but still. Okay, time limit's a bit more generous. Time limit's 4 seconds, which is unusual. Maybe it really isn't like a full symmetry. Maybe we have to do some sort of trick with it. Okay, I know. Okay, oops. I know an XOR prop. I know the main XOR property where. Okay. Oh right, this was the XOR expression. Okay, operator. This is the same as this. So if I have my original number and I do some XOR, and then I do some XOR, and then I need to do another XOR, I can just XOR the queries themselves, what's on my lazies, so I don't have to worry about like these stacking up because I can just like XOR on that itself, like the original, the one that was in the lazy. And I also know that the XOR identity is 0, so it's gonna be easy to work with like our elements in the lazy symmetry being 0. So okay, second query I'm done with. The first sum query I gotta deal with, I guess. Fuck. And by the way, guys, it's 2:14 a.m. My brain's barely running.
Imagine if bro was recording this entire time. Oh my god.
What?
Imagine if you weren't recording the entire time.
Nah, I am. Bro, that'll be crazy. I don't mind though. I can always record another problem, but that'll be funny. That would have been funny.
Did you do your intro?
Oh shit! No, I forgot to do my intro. Okay, guys, I'll do my intro right now. Watch this. Yo, man. What's good, y'all?
You don't even have your camera on.
I don't even have my camera on.
Oh, it's.
I do, bro. Okay, it's on the OBS. It's not on the Discord. Young
I'll
goofy.
leave the call because I think it's lagging your computer right now.
All right.
I can see my screen.
How do I arrange some? That's what?
Why is the voice channel called Steaming? Steaming.
I made a typo. Can y'all Oh, wait. Okay, I'm the owner. I'll give you guys admin. I made the server today, so hell no. Should we just keep it as steaming? Wait, hold on, I'll pause my timer. Steaming, okay.
Steaming J Chungus.
You know in Cookie Clicker, there's like an achievement called steamed cookies. If you import like a Steam save to the online version.
Steam cookies. Bro, my thighs hurt so much. Yeah.
I love thighs.
The body thing like pain me so hard.
Same. Alright, I'm back to the problem, yo. Okay. Welcome R. Range some query. Usually this would be easy as fuck. I think I'm tripping on a really easy problem. Stack.
David loves the shoe guy. You're doing it. People know who the shoe guy refers to. I thought they know, bro.
Oh, you know what? Let's try to do the first query by hand from range 1 to 3, so that would be 4th, 10, 3. The original sum would be, let's say we'd add the 14 and then we add the 14 and the 3, and let's say it kind of works like that, okay? If we apply the XOR, I'll just search up XOR calculator. 3, okay. 4, 3, 7, 10, 3, 13. And I know 3 is probably 0, right? Yeah. So it's 20, and then it's 20. What if we do 17 and 3?
GG's.
Yeah, this is something completely different. So it's not a simple application. Which pisses me off, bro.
Yes.
Ho ho ho. I think we need to quickly come up with some sort of observation relating to XOR and this range query.
Let's try and make 10 creams before the move.
I remember this reminds me of this range GCD problem where you had to keep a separate array of the difference of each element, and then you can rebuild the GCD based off the difference because of the Euclidean algorithm. I think this should have some sort of similar observation where you don't necessarily just XOR. Can we actually, like... No, there's no way. I'll just like keep talking and try to pull out something from my line of thought. You can't XOR the sum itself, but you can XOR the leaf nodes, and then you can combine. But that results in linear time per query. Maybe we need to keep another different sort of segment tree. Okay, I think we really need to find an expression relating to like A XOR X plus B XOR X equals something in a more simplified form. And for that, I have no clue. We're going to have, I know that we're going to have some bit representation of A, B, and X, and then we're going to apply some sort of XOR to A, apply some sort of XOR to B. Oh, but if we know what's different between A and B, if we query 1, if we know A, then we know those parts are different. What I'm trying to say is, like, if A is something, X is something, and we apply XOR, we're going to get a number. But because of how XOR works, let's say B is similar to A, but this one part is different. Then we know that this value, after applying the XOR, will also be different. So we XOR A and B. Through that, we know what indices are different. So if we XOR A, B, this is going to be... Is that it? No, that feels really weird though. So that means B equals A XOR X. If we remove these from both. No, that's kind of bullshit. Hold on. We get the representation of A XOR X. Oh, wait, is it something like this? Because if we rearrange it, we get like something like that. So that makes sense. So if we represent that, try to represent that again, I have no idea if this will fucking work, but okay, we're getting somewhere. We're definitely getting somewhere. We can, okay, it's super easy to track XOR between elements. This is gonna be easy. So if we apply one of the leaf nodes, now that's still a shitload. We can't optimize simply by calculating only one leaf node update. That's still gonna require a lot. We need some slightly more generalized form. But I definitely think this is the way of solving it. Wait. But that property holds for all elements, so like this would just be like, what if we pretend we have a 0? And we represent this as okay, that's not it, but damn, okay, we're getting somewhere. Hold on. Shit, okay. That's huge. So if we're given a range, we only XOR the leftmost one, then we reference the no. Because this way we still need to apply that XOR individually. That this really doesn't change much. This is just like a different way of writing it, I guess. Right. Because we still need to add them back. It's best if we get rid of that plus somehow. How do I fucking solve the other one? The diamond 4 problem in the other online judge. Can we chain this somehow? So, because this would be this, but we know that this is... I feel like this is just complicating things. But it can be written out this way, so... Okay, maybe this idea seemed a bit plausible, but it's just complicating things. This is a way of like figuring out one based off the other, not doing something with the actual sum itself. Okay, let's think of the meaning of XOR itself. Anything that's the same becomes 0, different becomes 1. If we apply it on a number, can we change XOR to some numerical method? Like is there a way of just writing that out? Like 17 in binary would be like that. And 3 would be this. So XORing them would be am I tripping? That does not look like a 14 to me. Oh, hell no. Let's go back to this example. Maybe I was hella tripping. Okay, these two are the same, obviously. Okay, the leftmost bit, anything after that can't affect my number, so it's only going to have effect until this place. How's an XOR different from a minus? It's completely different. I don't think I can. No. Okay. I apply the XOR to A. I apply the XOR to B. And B can be represented as A XOR X XOR the difference of A and B using another XOR, which we did find out. If we say the new number is T, that's that. Okay, so given a sequence of numbers, if we want to XOR one, like a range, then we XOR the leftmost. And then for the next one, we just XOR again. And we keep an XOR separate array of these, like the neighboring ones. Then we apply this as an XOR. This is way more complicated if we need some. Yeah, this is like a million times harder. This way. Why is my laptop burning? Do I have like cookie clicker on? What the fuck? Alright. Fuck. Am I dumb? Maybe if I fix my posture, I'll get a new idea. What are you doing?
Doing this while grinding infinite.
Oh, okay. I need a new line of thought. Maybe I'm stuck here. Okay, start fresh. We know lazy XORs are a thing. We just want to figure out how to apply those on a, like, get the range sum after we've applied it on a range. Do you think I should just search up how XOR plus another XOR works? I mean, I think that should be really generic. It's kind of like pointless to be struggling on this right now, because there's no way this is not a common problem. I'll probably never see a problem like this in my life again after solving. You know what? No. That defeats the whole problem of solving the problem, because I won't see it anyways, but I still want to solve this because I want to learn through the process of like using XOR. So, okay. I'll just move this over to this now that I have my. Yeah. Let's write it again one more time. Maybe I'll write like this version again. Stare at this shit. can I fucking do here? I range XOR. Maybe I'm making a mistake on the propagation part. I propagate, can do all that, but I don't know how to directly apply it in a mid like sum. But I do know everything's gonna be the sum of 2. But that goes down until the leaf nodes, which, I mean, yeah, because, okay, if we want to figure out the updated sum, yeah, here's what I'm thinking. I'll just draw it in MS Paint. I have a node. There's going to be 2 vertices, another 2 nodes, other 2 vertices. Let's say I want to apply XOR on this whole range. I want to get the sum query for this. I'll apply XOR to that and that. And then after I get the results, I can sum those 2. But to get the result of that, I need to go until the leaf nodes, check it on every single leaf node, and then it's going to go all the way down and back up if we somehow build some recursive call. And that's linear time. We don't want that. So either we somehow figure out how to directly apply an XOR to the sum itself, which I don't think is the idea, because, bro, that makes 0 sense. Like, what the fuck? Like, how is okay, maybe we should think about that further. Maybe we're missing out. Like, I have some number. And I have another number. The sum is relatively easy to get. I just fucking... Just get the sum. XOR, just get the XOR. The relationship I see between these two. No, I need to do another XOR. What did I even do for the XOR? Oh, I XOR'd the 2, okay. Do these two have some correlation? The first digits are all the same. It's just that plus raises another one further. So this... No, like this is technically this. Fuck, I'll go slowly. This is this, but we raise. No, but if we raise one, that can keep raising on and on like a fucking chain. So, okay, starting from the rightmost, 0, 1, all these 3 cases, they're the exact same. But if we get to this case, we have to keep raising. Okay, it's whatever way. I don't think we can fully represent a plus b using like Boolean operators only. I don't think that's the whole point. I don't think like the point is just to get poom, poom. Then you just somehow come up with like you can instantly update the whole segment. Maybe we don't want to apply the XORs directly. Maybe that's not what we're going for. Maybe we should think of how to make the node structures then. Because if we can't, like, we're gonna have a sum. When we combine two nodes, it's still the same process. It's just for sums we add. Is there anything else we can store that will help us? No, because here's the fallacy I find. Like, let's say we have the number, like, 2. This 2 can be made up of 0 and, like, 2 in binary. Or it can be made out of this. If we apply 1 as an XOR, this becomes, like, that. And this becomes this. So the contents of their children. Oh, I should have thought of this fucking earlier. Okay, this disproves like a lot of points that I've like been wasting time on. It's impossible to just base our new sum based off like our current sum. Like instantly. But there might be patterns. Like there might be some sort of how much can an XOR change a number at max? It can change it up until no. Wait, persistent segment trees might be the fucking answer. The fucking memory just flashed by, holy shit. Okay, pause the timer. I'm gonna check what the problem that I solved was, and if I can solve that in my mind, like if I just like immediately see the answer to that, and see if like I solved the same problem before and I'm just like forgetting or not. That would not be good. Okay. Okay, that's easy. That's just stuff in itself. Okay, this is the XOR related thing. So we're finding the max after we apply the XOR, and this is getting the sum. For the max, we can just do the max after applying a certain XOR should be like, it's like string, like if it's x, it should be 1 minus x, but instead of 1 minus x, it's like the number of like the length of the bits, and it's like 2 times the length minus 1, like something like that. So if I have 2 children, okay, maybe I'm tripping. Maybe one and 3 I can do with PST. That's the memory, that flash, but it's not really useful here. 4 and 5 I can just do with just I can have just nodes for that. I mean structures for that. It's not hard. Alright, let's try to solve this first. Like the query number 2. And I'll see if I got it right in my mind. So it immediately does it and immediately returns. It doesn't like wait for anything. It just XORs and then it just pulls out the biggest Y. Man, am I stupid? Am I just like inherently horrible at XORs? Man, fuck this shit. I'm searching on XOR properties. Maybe there's something I'm forgetting. Sorry, yo. Okay, this is not it. Okay, I'll just check how I process this, because I think I'll just be stuck here forever, and I don't want to check the editorial like already. check for hints. So when I get the third query, oh, was it the third query? No, it's the second query. XOR query. Okay, what the fuck is this? I get X. What the fuck? That's my target for some reason. What did I return? What's the purpose of... Oh, okay. No. Okay. Per bit. Oh, fuck. Okay. So we do something per bit. Starting from the leftmost one. If we have that bit... Please count. Huh? Oh, okay. I guess we have like a add one query or something like that. What the fuck am I doing right now? It's a histogram PST. Not a the one I was expecting at all. Fuck, wait. Oh, we don't store the array values themselves? We check that version and that version. Okay, without looking at that, I'll try to come up with like, okay, we use histogram, and we get the minimum after applying the XOR. So we check per index. If it's 1, no, we want to check the maximum after applying. So if it's a maximum. Yeah, so if it's 1, we want to look for the left half, which has the ones with 0. And if it's 0, we want to look for the ones. And if we do have them... Oh! Okay, so that's how it works for maximum XOR. That makes perfect sense. That makes perfect sense. Do we use histogram fucking PST for this one as well? But we're applying a range XOR in itself. There's no way you can use a histogram on this one, right? No, we can because no. Okay, if we use a histogram, the range update itself would look something like where we just okay. I'll start my timer. Okay, then this way the range update itself feels more like we move every single element. Okay, let's do the same bit traversal. At a certain bit, if it's 1, yeah, if it's 1, then we're gonna flip everything that's on the 0 to the 1 and the 1 to the 0. So we just completely just swap the L child and the right child. And we just keep swapping. Oh, like those. What's that like baby ceiling toy? It reminds me of that. I'm just ignoring time for now. I really want to show you guys this analogy. Yeah, these. Like the. Yeah, these. Like, we're switching. If I represent it on like if this was a histogram, we have a left child and we have a right child, but we literally fucking like rotate on this pivot. We rotate on this pivot. We swap the addresses of the left child and the right childs for this query. That is fire. That is fire. For the sum, wait, no, simply like moving the childs wouldn't help. Okay, yeah. Changing the childs completely, that makes sense. Okay. Now this calculate the sum of current array elements on the sum. Okay, sum. After we've done all that swapping, every time we swap, everything's getting their value increased by half of that. Like, we're moving it from here to like here. So we want to add plus. How much the fuck that is? It's gonna be like half. Like it's half of that. Half of the whole range, like r minus l plus 1 divided by 2. Like basically like that. Yeah. So every time we update a range. If we keep track of a sum as well, we can update the sum, because the counts. Yeah, we're just multiplying this times the counts. And we're doing minus that for the count of this. And then we sum those, and then we keep a sum. Does that conclude it? I think it does. Okay. I'm not sure if it's right. I'm not sure if you guys understood what I was trying to say, but I'll try to explain one more time. If we take a look at the update queries first, like, okay, we'll have like a default histogram-based segment tree setup with sums as well by multiplying the counts times the index it represents. And basically, we're essentially swapping the left childs and the right childs whenever we want to. It like that XOR is a 1. That makes sense, yeah. Okay, I'm tripping out. Does that work? If it's 1 in that index, everything on here goes there. Okay, that makes, okay, what if it was 0? 0, nothing happens. No, 0, it still swaps. No, if it was 0, okay, fuck, if it's 0, if it's 1, since that digit was 0 here and 1 here, 0, 1 becomes 1, 1, 1 becomes 0, so that flips. But if it's 0, 0, 0 becomes 1, and 1, 0 is... Oh, 0, 0, 0. Okay. So if it's 0, it doesn't flip, and 1, it does flip. So we're just like rotating this as if we have like this system of orbits, like those like baby ceiling toys, whatever you call them. And then with this, every time we do a flip, we update the sum by adding the number of everything here times that new, like the amounts we fucking moved. Like we can consider this as one scope for moving to here, moving to here. It's gonna be the same. Even if we have like, even if it's not a fully binary and like perfect saturated binary index tree, it's still gonna work because like each node still has 2 children, and like in every case, it's just that somehow like more heavier and lighter. Okay, so when we just update the sum by plusing that times the counts and minusing that times the counts. Fuck, but the order of summing is really important because, okay, we proceed down the tree like that, but we want to update the sum from bottom. We want to add all the changes up. Yeah, we want to add all the changes up. I think I solved it in my mind. Yeah, we have to, okay, just to explain to you guys, we just progress down by doing the swapping, and then after we're done swapping, at the end of that, before we return from that recursion, we add a certain amount to the sum based on like the number of the left and right, like the count of the left and right children, and then we add up. Yeah. Anything I think we learned in one lesson today. I'm not even sure if this will work. I'll implement it in a bit, but yeah, these XOR queries histograms were pretty good. Okay, I'll pause my timer, and before doing anything, I'll look up if this similar problem exists in this online judge. If it does exist, I'm curious about its rating. Like, I don't think this is like an easy problem at all. I underestimated it. Like, okay, I'll go to their segment tree section and search up XOR. What is this? I don't know. Let's go down. They only have 3 XOR problems. Oh, there's whole different pages. I mean, you know what? Okay, there we go. Let's try the XOR search here. There's one. There's no way that's XOR tree. Bro, let me. Oh my god. Bro, on God, let me click the link, bro. That's not it. There's no way there's a. Like a. There's no way this doesn't exist. Okay, maybe the problem I'm thinking of doesn't really exist. Yeah, XOR on segment. Yeah, range XOR. Yeah, I don't think the problem exists on here. Okay, I'll try to implement it myself and see how it goes. I think I did solve it, but we'll have to see. Alright, I'll pause the stream. Forgot how to pause the stream. Oh, is it this? No. Yo! I'm back. I have to check if my live stream is running. Okay, it's back. Alright. So, I just took a short 10-minute break.
Took a shit.
Okay. I've solved the problem, but it was pretty fucking hard, okay? Maybe it's not that hard once you realize it's histogram based, but still, like, classifying this as like other things you're like like Gargari and bishops. Like this was a pretty easy problem. That's just I don't get it. I don't get why this is in the same class. This felt a lot harder for me. So what I'm gonna do is I'm gonna check the editorial. I'm gonna check the first line or a few lines until I'm certain that my solution is right. And if it's right, I'm gonna implement it. If it's wrong, I don't know what to fucking do then on. So yeah, let's see if my idea was right.
The moment of truth.
Okay, they used a different method. Is my solution wrong? Am I tripping? Let's think of why this is wrong. If it is. I swap. On the second swap. Oh fuck. Do I need to swap both of these? Next one I swap these so it's not logarithmic, it's n log n. Fuck. David. Apparently I think the thing I explained to you isn't gonna run in logarithmic time because you know how you like swap like the left and right childs?
Yeah.
I explained that part.
Yeah.
But can you check my stream right now? So basically,
Uh-huh.
on the first one I do it on this, right?
Yeah.
But that means for the second one I need to apply to both of these.
Oh.
And that grows exponentially and eventually that just becomes n log n, basically.
Oh.
No, it doesn't become n log n, it becomes 2n to be exact. 2n minus 1, but it's still like linear time, which is...
Oh my god.
Fuck, that is scuffed. I thought I came up with like a genius idea.
No, but the idea itself was kind of genius.
Yeah, okay, I think it was a nice try. It was a
Yeah.
nice approach. I just simply checked if that was the right idea or not. So I don't know. I know this is wrong, so I have to apparently go back to thinking about this and how to solve this. Alright. Fuck. Fuck.
At least you didn't waste time implementing.
Yeah. Oh, thank God. I would have killed myself. Okay. At this point, I think it's best to just, like, get a little hint. Yeah, I'm gonna get a hint. I think I'll just, like, be stuck here. I checked, like, the editorial anyways. Okay. Let's read a few words in the editorial. Try to get, like, a little grasp. Let's write numbers A1 on our sequence as a table which has size int 20. Bij is the jth bit in A. Fuck, that is creative. Holy shit. That is a crazy technique. Okay. Is that enough for me to just solve it right away? Because when we're given an XOR query, we update all 20. We can keep 20 segment trees, each containing that individual bit related stuff. When we give one, we update all of those 20 for certain bits. Is the solution super similar? Because like this way we still need to swap, right? Because for each index, you get the range. Okay, my brain doesn't work well right now. I'll keep my timer going. Okay. I'm drifting away. Okay, let's focus. We update each bit. For each bits, we swap out all zeros for ones and ones for zeros. So that's just gonna be that range. There's gonna be, okay, 0 becomes 1, 1 becomes 0. That just means we're subtracting that segment minus the sum of all zeros or ones or zeros. And then that's flipping. So once we have the sum, we, for all 20, we times 2 by the power of some. Okay, that's a good fucking solution. Okay, I got the idea. Whew. I'll be right back, guys. I want to explain this to my friend. Yo, I'm back. I'm gonna implement this. Dude, I rethought of the editorial. Like, I'm pretty sure I got it right. I mean, I read the first few lines and that was the only possible solution. Did I explain it?
No.
Did I? No, did I? Okay, did I not?
I don't think it did.
Okay. I might have, but just to explain it again in short, we just rip each one to like the bit level. So we have like 32 segment trees for each bit of that integer. We still store like the array itself, and when we get a range query, we update every single like bit level segment tree. And when we get the range LR, essentially what the XOR is doing is we're just flipping that bit. So like from range L to R, we can like just do our normal sum the normal way. Just for each, we have to have one for each 32 segment tree. So therefore our new sum becomes R minus L plus 1. So like the length of the segments minus the original sum. That becomes our newly updated sum after we flip. So that's, after that we get our new sum, right? So now that we have our new sum, we just, yeah, like we can just multiply that by the 2 by the ith power if it's that ith bit. Then we just add all of those. It only takes 32, like 032, which is a constant we can just ignore. So yeah, pretty good solution. One thing I'm not sure about though is if we can just like, oh wait, no, we don't query the sums. I mean, we don't update the sums after we, no, we do update the sums after an XOR. And when we do an XOR, if that bit is 0, nothing changes. If that bit is 1, it flips, and we can update sum that way. But then what about the child sum? Like, what about the children's sum? How are those updated? Do we need to update the children? I think we can lazy propagate that, right? Can we? Because, okay. We have a bunch of bits. And let's say we we need to flip these two. No. Oh, hell no. I'll just copy and paste shit. What the hell just happened? Holy shit, what is going on? There we go. Say if we update like this range, what happens? We get until this level. Okay, no. Let's say we update like this range. Then this sum gets updated. But what about the children's sum, you know? Yeah, because then we need to access the children's sum. We can't update every child. Can we? No. Okay, you know what? We're gonna lazy propagate that. We're gonna lazy propagate the flip. Yeah, that's a good idea. Yeah, we lazy propagate the flips. And then we can just, yeah, if it's one, we can just... Alright. Cool, we cool. Okay. Bro, we have to use fucking lazy propagation with this shit as well? Ah, hell no, man. Oh, bro, my honest reaction be like, oh, bro, this problem was disgusting, bro.
Nasty.
Okay, not gonna lie, it was cool. It was really cool. Okay, it's a good problem. It's a great problem. I learned a lot from this. I learned a shitload about this, like from this. Okay, let's implement. It's been over a fucking hour. If this was a real competition, I'd be cooked. I'd be chopped. I'd be fucked. How many bits do we need? Honestly, I just want to do 32 for safety, but 10 by the power of 6. How much is that? Log 2 cook. Can't believe I'm fucking searching this up. My dumbass. How many zeros were there? 6. 20 bits. I'll do 21 for safety. It doesn't even fucking matter. You can just do like 32 doesn't. They can do like a fucking 1,000 bits. Nobody would care. Okay, my PC is running low on battery. You know what, guys? I'll go to my room. Yeah, and I'll just finish implementing this. I'll live stream this, but I won't talk. And it's simple anyway. So, yep. I'll see you there.